Good morning, my YouTube viewers. It's Crystal here. I'm just here this morning because I wanted to make another video for you, and I wanted to make this video. It's a Kaggle's Playground series, season 4, episode 4, and it's to do with the Abalone dataset. And actually, to be perfectly honest, the Abalone dataset is in the Tensorflow library documentation, so you didn't have to do very much to do it. If you studied Tensorflow, then you would know that the Abalone dataset was in there, and you would just be able to use some of the code from Tensorflow, which is basically what I did. And I did the competition about a day before yesterday. I'm also having problems making recordings, so this is going to have to be quick, because if it doesn't record properly, I don't know what I'm going to do. So I might have to buy a recorder and attach it to the outside of my computer and see if I can get it to record better that way, because there seems to be a problem whenever you try to record using Xbox, which is what I use. So in order to not waste time, I'm going to go ahead and go through the code review. It's a regression with an Abalone dataset, and as I said, this Abalone dataset can also be found in the Tensorflow library. So what we did is we created a program in using Kaggle's Jupyter Notebook, and then what I did was I imported all of the libraries that I would need at the beginning, and then Tensorflow and other things, then I imported them as I would need them. So the libraries that we imported were NumPy, which creates an NumPy array and also performs numerical computation. Imported Pandas, which creates data frames and also processes data. I imported OS, which goes into the operating system and retrieves the files. I imported sklearn, which provides machine learning functionality. I imported Tensorflow and Keras, which provide deep learning functionality. I imported matplotlib.pyplot as PLT, which visualize the data, and then I imported Seaborn, which also visualizes the data. I used OS to retrieve the files from the operating system, and we've got train, test, and sample submission CSV files. Then I use Pandas to read those CSV files and convert them into data frames. So we've got the train, which has ID, sex, length, diameter, height, width, whole weight 1, whole weight 2, shell weight, and then rings. So the rings is going to be the age. I created the test data frame, and it doesn't have rings because that's what we're going to be predicting on. Then I created the submission data frame, and that is the format that Kaggle is going to want to see when that's the format that Kaggle is going to want to see when we submit our work. I dropped the ID column from the train and the test, and the reason why is because Pandas automatically indexes every row of data, so you don't need the ID. It's just going to be extra information that's going to bog the program down. I analyzed the target by popping the rings out of the train data frame and using Seaborn to create a histogram, so you can see that's what the target looks like. Tells you how many rings they have. So the most commonly used number of rings, I think, is around 10, I believe. 9 or 10 is the most commonly used number of rings. And then so you have some rings that go all the way up to 30. Now what we're going to do is we're going to analyze the sex, because the sex is a categorical value. So we have 3 sexes being F, I, and M. So what I did was I created a dictionary. I is 0, F is 1, M is 2, and I replaced the letters of the alphabet with numbers, and then so I replaced the dictionary with I replaced the letters of the alphabet with the dictionary in the columns of data. So you can see what we've got here with the sex, and you can see that it's no longer letters of the alphabet and it's now numbers. So now what we did is we used Seaborn to create a heat map of the columns, and then when we created the heat map of the columns, you can see that most of the columns of data are pretty highly correlated. But the thing is if you remove columns of data, then what's going to happen is you're going to lose, sometimes, not all the time, but sometimes you're going to lose accuracy. And so I decided that since there are not that many columns of data anyway, then what I would do would be just to leave all the columns of data in there except for ID. Now we're going to standardize the data set. So train equals train minus train mean over NP STD train. Test equals test minus test mean over NP STD test. And now we're going to define the X and the Y variables. So your Y is your target, your X is your train, and your X test is your test. Now we're going to use sklearn's train test split to split the X and the Y variables up into training and validation sets. And you're also going to look at the shape to make sure that you've got it done correctly. And now we're going to create our model with Tensorflow. So we're going to import Tensorflow as TF from tensorflow.keras import layers, and then we're going to print the version of Tensorflow. So now we're automatically on version 2.15. So Tensorflow goes through a lot of changes, a lot of revisions, so it's important to keep up to date with Tensorflow. And I know that I need to do that because I had been working on JAX and then FLAX, but there wasn't a lot of documentation on JAX and FLAX because that's mainly for people who are researchers. And then I had to make the decision to go back to Tensorflow because there's more documentation on Tensorflow. So I'm going back to Tensorflow, and I'm going to be using all of the Tensorflow libraries and see if I can improve upon my machine learning techniques using Tensorflow. So we created our model. This model that I actually got from the Tensorflow library. Abalone model equals tf.keras.sequential, layers.dense is 64, and then the last layer is 1 because it's a regression model. Then we're going to compile it. We're going to use the loss as the mean squared error, and we're going to use the optimizer as Atom. And I will say that I did try other optimizers. I tried Lion, and then I tried SGD, but Atom still outperformed those optimizers, so that's what we're sticking with today. So now what we do is we train the model, and I had it trained for 30 epochs. I'm sure if I had it trained for more epochs, I would have had less noise, but I just had it trained for 30 epochs. And you can also, with the Atom optimizer, you can also change the learning rate, make the learning rate smaller. That may have increased the score. I may actually try that, see if I can get the learning rate smaller, and see if that increases my, decreases the noise. So now we create a summary of the model, using summary. And then what we do is we predict on the validation set. And so this is our prediction, our YPRED, and then we use sklearn's mean squared error to check on the error rate of that, and the error is 2.09, which isn't too bad. And we create a data frame of the actual values versus the predicted values, so you can see how the actual values compare to the predicted values. And then what we do is we use matplotlib to plot the actual values against the regression line. And now what we're going to do is we're going to predict on the test set, and pred equals abalone model dot predict x test, pred equals pred less than 0 equals 0, pred equals pred dot s type int, and then pred dot flatten. And then so there's your predictions. And then we prepare our submission. Submission rings equals pred submission.2csv, submission.csv index equals false, submission equals pd read csv, submission csv, and then so we've got our submission. And so that's it. That's what we got. And then whenever I ran it, when I saved my work and submitted it to Kaggle, I got a 0.17, which isn't too bad. It isn't too bad. But if you go to the leaderboard, there were people that scored a lot better than what I did. So if I wanted to, I could try to change my learning rate, see if that would improve my score, or increase the epochs and see if that would improve my score. So because I'm having problems with making videos, I'm going to go ahead and conclude this video. And so I'd like to thank all of my subscribers for supporting my channel. And if you like my video, please like, subscribe, and share. I look forward to communicating with you in the next video.